stand in a field with me for a second. It's dark, and I ask you to point straight up, at the sky over your head. Good. Now point the exact opposite way, down past your feet, out through the earth, at the sky on the far side. Two patches of sky, about as far apart as two directions can be. And here is the small, quiet fact that has been ruining my week. Those two patches are the same temperature. Not close, not near enough for company. The same, down to a whisker. And you'd think that was the dullest thing anyone ever told you, right up until you ask the obvious question. How did they agree? And the honest answer comes back, they can't have. They've never met.
They've never met. Sit right there, because you've walked in the front door carrying the exact thing I meant to spend the whole evening handing you. That little fact is not little. It's one of two unpaid bills the universe left lying on the table, and for a long time, nobody had the money to settle either of them.
Unpaid bills. I like that already, and I don't trust it at all. Whose bills?
The baby photos. Cast your mind back a few chapters. The oldest light there is, the afterglow of the fireball, arriving from every direction in the sky at once. We called it the universe's own baby photograph, and I told you it was the closest thing to seeing the infant universe directly that we would ever get.
I remember. It's the light as a time machine trick again, isn't it? Look far enough out, and because the light took so long to get here, you're looking deep into the past. And the baby photo is the deepest look of all. The fog clears, the young universe cools enough for atoms to hold together, and the light that had been trapped in the murk finally streams free.
That's the one. That freed light, stretched out over the ages, reaches us now as a faint microwave hiss from all over the sky. And the astonishing thing about it, the thing we said to hold on to, is how smooth it is. Point your instrument up, same faint glow. Point it down, same. Left, right, ahead, behind, the same temperature everywhere you look, to a sameness that ought to frighten you a little.
And at the time you told me to be frightened later. You literally put the puzzle on layaway. You said, "Hold that, we'll come back for it." I felt very grown up being handed a mystery I couldn't afford yet.
Well, here we are. We've come back for it. And to pay it off, you and I have to go somewhere we've never once gone in this whole series. Further back than the fireball. Further back than the first atoms, the first light. All the way to the first sliver of the very first second.
The first second, not the first few minutes where the furnace cooked up the hydrogen and helium. Earlier than that?
Earlier than that by an amount you have no feeling for, and neither do I. Last time out, remember, we caught the universe doing something outrageous, speeding up. Right now, the expansion accelerating instead of slowing. And I promised, at the very end, that if you thought that was strange, wait until we run the film the other way.
You did. You said, run everything backward, past the fireball, to the very first flicker. And the universe looks like it took one colossal leap. So this is you cashing that in.
This is me cashing it in. But before I show you the leap, I have to make you feel the debts. Really feel them in your stomach. Because the leap only earns its keep if the debts are as bad as I say. So, the first bill, the one you brought in the door yourself.
The two patches of sky that agree and have never spoken.
The two patches that agree and have never spoken. Walk me into your own objection. On the face of it, where's the crime?
Honestly, I don't see one yet. Two bits of sky are the same temperature, big deal. 2 cups of coffee left on the same counter come out the same temperature. Things even out. That's just what things do. It'd be weirder if they didn't.
That's the instinct, and it's a good one. So let's honor it rather than swat it. Why do your 2 cups of coffee even out?
Because they're in the same room, breathing the same air. Heat leaks out of the hot one, the room shuffles it around, the cold one warms a touch. They trade back and forth until they land in the middle together. They even out because they're in contact, because they can talk to each other.
Because they can talk to each other. Write that on the wall. It's the whole evening. For two things to agree on a temperature, something has to actually pass between them. Heat has to be carried across, by the air, by touch, by light, by something. There's no magic by which two separate things simply decide independently to match. They have to trade first.
Fine. So the two patches of sky traded. They evened out the same way the coffees did. Still not seeing the crime.
The crime is in the trading. What's the fastest a message of any kind can cross from one patch to the other? The very fastest anything in the whole universe is allowed to go.
Light. Nothing beats light. You drilled that into me across 2 entire seasons. Light is the speed limit, the thing you can't outrun, the fastest a nudge or a signal or a scrap of heat can possibly travel.
The fastest anything can travel. So for your two patches to have traded heat and evened out, light itself had to have had the time to cross from one to the other, at least once since the beginning. A signal had to make the trip, or no deal.
All right, and you're leaning in, so I take it the trip is where it falls apart.
Take those two patches on exact opposite sides of the sky and ask honestly, in the whole history of the universe, from the very beginning up to the moment that light was set free, has light had the time to make that crossing even once?
And you're about to tell me it hasn't.
It hasn't come close. Not once. Not a fraction of the way. The two patches are so far apart that in all the time there had ever been, a beam of light leaving one of them could not have reached even a little way toward the other, let alone got there, traded heat, and settled things between them. They are, in the plainest possible sense, out of touch. They always have been. And yet, they match.
Hold on, though. Hold on. I've got the escape hatch right here in my pocket. They match because they came from the same place. Rewind the whole universe. Everything crams together, hotter and denser, back and back. At the very start, it's all squashed into one tiny spot. So, of course, the two patches are the same. They were the same thing once, touching, right at the bang, and then just carried apart. Same origin, same temperature, no mystery. There. Did I just pay your bill for you?
You made the move everyone makes, and it's the right move to make. And it is wrong. And finding out exactly why it's wrong is the best thing you'll learn all night. Cast your mind back to when we rewound the universe to the fireball. What did I bang on about, over and over, until you wanted to throw something at me?
That the Big Bang wasn't an explosion at a point. It didn't go off in one spot in the dark and hurl stuff outward into empty space. It happened everywhere at once. Every scrap of space was dense and hot, all of it, all over. No center, no edge.
Everywhere at once, so there was never a single spot. Never a moment when your two patches sat on top of each other, shaking hands at one shared address. Even at the very beginning, they were already apart. The fireball filled everything. Being early doesn't put everything in the same place. It just makes everything denser, everywhere at once.
Ah, so they started together is quietly smuggling back in the exact picture we already threw out. A single point they all touched at the start.
There wasn't one. Let me give you a cleaner version to hold. Two runners crouch at the start line of a race, side by side, close enough to nudge each other. The gun goes. Now, the fact that they started at the same line, does that let one of them hand the other a note halfway through the race?
No, the note still has to be carried across. Somebody's got to physically run it over. And if they've both sprinted off in opposite directions,
as fast as their legs will carry them,
then the note never catches up. They started an arm's length apart, and they still can't get a message between them because the gap opens faster than the note can close it. Starting together isn't the same as touching. Touching means a message actually made the trip, and here it never could.
And in the young universe, the runners are sprinting apart faster than the note can chase. The space between the patches opens up so briskly that light, the fastest note there is, never once makes the crossing. So your two patches of sky are like two runners who started near each other, ran their whole lives without ever passing a single message between them.
And then you meet them at the finish line and they're wearing the identical outfit, down to the stitching.
Down to the stitching. That's the scandal, not that they match. That they match and could never once have arranged it.
And it isn't just my two dramatic patches, is it? You picked the two on exact opposite sides to make it vivid, but you're telling me this is the whole sky.
The whole sky. Quilt it into little patches, the size of, a coin held at arm's length roughly. No need to be fussy. Each patch is about as far as light could have travelled since the beginning. So each patch could settle its own temperature on its own internally. That part's fine, but patch to patch, across the sky, none of them ever had the time to compare notes with the ones beyond arm's reach.
And every last one of them came out the same temperature anyway.
Every last one, to a whisker. Picture thousands upon thousands of separate little rooms, no doors between them, no vents, no shared air, no way in or out for any signal. And you walk from room to room to room to room, and the thermostat reads exactly identical in every single one. Nobody set them. Nobody could have.
Okay, yeah, now it's crawling under my skin the way it's clearly under yours. That's genuinely wrong. That shouldn't be allowed. The universe is not supposed to be able to coordinate a thing it never once had the chance to coordinate.
It shouldn't. And a universe that pulls off a stunt it had no way to pull off is a universe that's hiding a chapter from you. Something happened that isn't in the standard story. This one has a name, by the way. The horizon problem. The horizon being just the fancy word for how far light could have reached, how far any signal could have got. And everything out past everyone's horizon agrees anyway.
Right, I'll hold that bill open. What's the second one? You keep saying there are two.
The second isn't about the baby photo at all. It's about the shape of space itself. Tell me, when you draw two lines starting off side by side, dead parallel, on a flat sheet of paper, and you run them out, what do?
They stay side by side, forever. Never cross, never drift apart. That's what flat means, isn't it? Parallel lines mind their own business till the end of time.
That's what flat means. But space doesn't have to be flat. Space can curve. You learned that the hard way over the last whole season, mass bending the very shape of things. Space could be curved so your two parallel lines slowly bow together and eventually cross, like the lines of longitude running up a globe. Or curved the other way so they bow apart and race off from each other. Flat is only one option out of a whole range of possibilities.
And flat is the one dead in the middle, the one balanced right between bowing together and bowing apart. So let me guess where this goes. We go out and actually measure the shape of space, big triangles, light from clear across the universe, and we find it's
flat. As flat as we can measure, and we can measure it awfully well now. Parallel lines laid across the whole cosmos stay parallel. The universe is sitting right on that knife edge, right in the exact middle of all the curves it could have chosen to be.
All right, but is that actually a problem? Maybe flat is just what it happens to be. Some universe had to have some shape or other. Why is landing on flat any weirder than landing on curved?
Because of the knife edge, and here is precisely where it bites. Flatness isn't a stable resting place. Try to balance a pencil perfectly upright on its point. if it's leaning even a hair to one side, what happens next?
It tips, and not gently. It accelerates over, the lean feeds on itself, gets worse and worse, and it's flat on the table before you can blink. A tiny lean now becomes a total collapse in no time at all.
The shape of the universe is exactly that pencil. If space had started even a hair's breadth off perfectly flat, a whisper of curve, one way or the other, that whisper would have grown and run away with itself, faster and faster, over billions of years. By now, the universe would be wildly, unmistakably curved. You wouldn't need a delicate measurement to see it. The tiniest early lean would have become a total fall.
But it hasn't fallen. The pencil is still standing there on its point.
Still standing on its point. After billions of years of the single most unstable balancing act imaginable, you look up, and the pencil is boringly, perfectly upright. Which tells you what about how it started?
Which tells me that at the very start it wasn't just nearly flat, it had to have been insanely flat. Ludicrously, ridiculously, impossibly flat, balanced so exactly on the point that even after all this time it still hasn't found a way to tip. That's not some universe had some shape. That's a universe that was set up with a jeweler's precision.
That's the second bill. We call it the flatness problem. And notice it has the very same flavor as the first. It's not that being flat is impossible, it's that flatness this fine, this exact, cries out for a reason. A pencil you find still balanced on its point after all these ages. You don't shrug and mutter, "Lucky pencil."
You say, something is holding it up there. Somebody set it just so. What?
What? So now you've got two bills on the table and no wallet at all. Opposite skies that agree without ever having talked, and an entire universe balanced on a knife edge it should have toppled off of eons ago.
And you're grinning, which means, I know you by now, you're about to pay both of them with a single coin.
With a single coin? That's the beauty of the thing, and it's exactly why this idea took the world by storm the moment somebody first had it. One move, one single audacious move in the first sliver of a second, and both bills are paid at once. And then a third gift you never even asked for falls right out of the register. So, take a breath. Here's the move.
I'm braced. Go on, hit me.
In the first unimaginably brief instant of the universe's life, the first sliver of the first split second, before the fireball we know, before any of the ordinary story gets going, the universe did not expand gently the way it does now. It ballooned.
Ballooned how much?
It doubled in size, and then doubled again, and then again, and again, and again, faster than doubling, going from smaller than anything you could put a name to, out to unspeakably vast, in less time than it takes you to say the word instant.
Doubled and doubled and doubled. And how many times exactly?
More times than you'd ever care to count, and I mean that as physics, not as a dodge. Over and over and over, each doubling hard on the heels of the last, so many of them that a patch far smaller than the tiniest thing you can picture got stretched out bigger than everything we can see in the sky today. That is the burst. We call it inflation.
Inflation.
A colossal, runaway swelling of space itself in the very first flicker of time. And then, almost as suddenly as it began, it was over.
How long did it last? Give me something. Was it quick?
Quick isn't the word. It was finished before the universe was any age you could put a name to. A flash inside a flash inside a flash. And here's the part that ought to make your hair stand up. In that unthinkably brief snap, space did more stretching than it has managed in all the billions of years since. The whole long history that follows is a slow afterthought compared to that first blink.
Okay, that's a lot to take in, and I've got about 4 objections stacked up. And the loudest one I'm just going to blurt straight out. That's the Big Bang. You've just described the Big Bang, the explosion, the everything flies outward, the great bang at the start. You've slapped a fancy name on the bang and sold it back to me.
No, and I love that you said it, because everyone says it, and getting this one wrong is how half the confusion in the world gets started. Inflation is not the Big Bang. It is not the explosion. Let me hold three separate things apart for you, very carefully, because a great deal of understanding cosmology comes down to never once blending them.
3 things, all right. Lay them out for me. Slowly.
Thing 1, the Big Bang itself. That's the whole hot, dense, expanding history we've been telling all season long. The fireball, the cooling, the furnace that cooked the light elements, the fog clearing, the afterglow streaming free. The ordinary story playing itself out over the long, long ages. That's the familiar one.
The familiar one. The universe as an expanding, cooling fireball. Got it, Cage 1.
Thing 2, the acceleration we found last time out. The gentle speeding up of the expansion happening now in the late universe. That mysterious dark energy giving space a soft, patient push outward. Slow, stately, going on all around us, quietly, even as we sit here talking.
The slow one. Happening today, Cage 2 and Thing 3.
Thing 3 is inflation, and it is neither of the other two. It's a violent, ferocious, over in a flash burst. The most extreme thing that has ever happened, anywhere, ever. Packed into the very first sliver of the first second, and then finished, done, gone, before the ordinary hot story has even begun. Not the bang, not today's gentle push. A savage little chapter right at the very front of the book, written in a completely different ink.
But hold on, Thing 2 and Thing 3. They sound like the exact same trick to me. Space accelerating, swelling faster and faster. So is inflation just the dark energy from last week, cranked all the way up to a scream?
They rhyme. They genuinely do rhyme. Both are space swelling in a runaway way. Both are accelerated expansion, and that resemblance is a real clue. And honest people lie awake wondering about it. But no, we do not get to say they are the same thing, and I won't pretend to you that we can.
Why not, though? If they're both just space accelerating.
Because inflation was more violent than today's gentle push by an amount that isn't even worth trying to write down. And it happened at the very beginning and then switched itself off. Where today's dark energy is feeble and mild and only switching on late in the story. Same shape of behavior, yes, wildly different scale, wildly different era, and driven, as far as anyone can tell, by entirely different stuff. Cousins, perhaps, not twins. And nobody has ever proven they're even related.
Cousins, not twins. Fine, I'll take it. And one more, because you keep insisting it's not the explosion, then what set the fireball going? If inflation isn't the bang, where does the bang itself come from?
And that's the honest, hard edge. So let me tread carefully. Inflation is not the thing that caused the Big Bang. It's not the match that lit the universe. It's a burst that happens in the earliest moments, and when it finally spends itself, when the swelling stops, it leaves behind a universe that's hot and dense and expanding in the ordinary way. It hands you the fireball, ready to go.
So, inflation comes first, and the ordinary Big Bang story we've been telling all season is just what's left over once inflation burns out.
That's the cleanest way to hold it. Inflation is the first breath. The fireball is everything that comes after the breath. And what came before the breath, what actually kicked off the whole thing in the first place, that we honestly do not know, and I'll come back to that before the night is out.
Flash, then fireball, then gentle push. 3 separate animals, 3 separate cages, and I promise I won't let them out to mingle. Now, you promise this flash pays both my bills with 1 coin, And so far, all you've done is tell me space through an enormous tantrum at the start. How does a tantrum settle a temperature and balance a pencil?
Now we get to the good part. Let's pay the first bill. The two patches that agree but never talked. Go all the way back to that little coin-sized patch, the one small enough that light could get clear across it. Before the burst, before inflation ever fired, how big was the whole region that's destined to become everything we can see?
You tell me. Tiny, I'm guessing, from the way you're leaning in over the table.
Tinier than tiny. Before the burst, the entire stretch of universe that will one day fill our whole sky was crammed into a patch so small that light had all the time in the world to cross it, back and forth, over and over, many times.
So everything in that little patch was in easy reach of everything else in it.
In easy reach. Heat sloshed around freely, corner to corner. It all touched. It all traded. It all evened out. The easy way, the coffee cups on the counter way. One cozy little region, thoroughly mixed, sitting at one single shared temperature.
Because when it's that small, there's simply no problem at all. Small things have all the time they need to talk to themselves.
And then, inflation. That one tiny, cozy, already agreed patch gets grabbed and stretched, doubled and doubled and doubled, blown up until it is larger than everything we will ever be able to see. And when the dust finally settles and the ordinary story plays out over the ages, that one little patch has become your whole sky. Both your patches, the one over your head and the one under your heels.
And they're the same temperature because they used to be the same patch. Oh, that's lovely. They agree because they were once one tiny region that had all the time it ever needed to sort itself out, back when it was small, and then inflation flung the pieces so far apart they wound up on opposite sides of the sky.
On opposite sides of the sky, too far apart ever to speak to each other again. And that's the whole trick. Feel how neatly it slips the trap. Inflation didn't make the two patches talk faster. It didn't speed up any conversation. It took a region that had already finished its conversation, already agreed its temperature comfortably while it was small, and it hurled the pieces clear to the ends of the earth.
So they match because of a chat they had long, long ago, back when they were next-door neighbours, before they got exiled to opposite horizons and lost touch for good.
Long-lost twins, separated at birth, turning up in the identical outfit. Not because they signalled each other across the void, but because they picked it out together before they were ever separated. A shared childhood, and then one very violent move. That is the horizon bill, paid in full.
Quick one before you go on. When you say a patch smaller than anything got blown up into our whole sky, do you mean the entire universe was once smaller than a single atom?
Careful, and I'm glad you asked, because it's a trap. The part we can see, everything inside our own horizon, that was once a tiny patch, yes. But the whole universe may be vastly bigger than the part we can see. Maybe endless. Inflation blew our little patch up into the sky we can survey. It never had to be the whole of everything. The universe was smaller than an atom is one of those tidy phrases that claims a great deal more than anyone actually knows.
But wait, now my faster-than-light alarm is going off, and it is loud. You keep saying the pieces got flung apart faster than light could ever cross between them. That's the whole reason they can't talk anymore. But you spent 2 entire seasons swearing to me that nothing goes faster than light. Nothing. Ever. And now space is flinging things apart faster than light in the first instant? Did we just quietly break the one rule you told me was unbreakable?
The best objection of the whole night. And I was genuinely hoping you'd catch it. No, nothing broke. Think all the way back to the balloon. Paint 2 dots on it, blow it up. The dots rush apart. But is either dot actually moving across the surface of the balloon? Is either dot running anywhere at all?
No, the dots just sit there. It's the rubber between them that's stretching. They get farther apart, sure, but neither one is actually traveling anywhere. It's the space between them that's growing.
And there is your whole answer, entire. The rule, nothing outruns light, is a rule about things moving through space. A runner, a rocket, a signal, a beam of light. Nothing traveling through space can beat light. But the stretching of space itself, that rubber swelling between the two dots, that isn't anything moving through space at all. That's space doing its own private thing.
And space is allowed to stretch just as fast as it likes.
As fast as it likes. There's no speed limit on the growing of the gap, because the gap isn't going anywhere. It's not traveling. It's simply getting bigger.
So the two patches never actually moved. They sat perfectly still, like the two dots. It's only that inflation poured an insane amount of brand new space in between them.
An insane amount of new space in one flash. So much of it that light, poor light, plodding along at its fixed pace through that swelling gulf, could never once hope to cross it. The patches didn't flee from each other. They stayed put and let an ocean of space open up between them. No rule broken. It's the very same lesson you learned watching the far galaxies recede. It was never things flying away through space. It's always space itself, quietly unfurling.
Okay, I can hold both of those at once now if I concentrate. Nothing moves faster than light through space. Space itself has no such manners. Good, so that's bill 1 paid. Now, what about my poor balanced pencil? How does the same tantrum go and flatten space?
Even more simply, and you already have the picture right there in your hands, from the balloon. Take any curved surface at all. The skin of a balloon, the surface of an orange, the ground beneath your feet. Now blow it up enormously. What happens to any small piece of it?
It gets flatter. The bigger you blow the balloon, the flatter any little patch of its skin looks up close. Stand on the ground and it looks flat to me, even though the whole Earth is a great ball, precisely because the Earth is so enormous compared to little me that my own patch of it looks flat.
And that is the entire answer, nothing more to it. Whatever curve space happened to have before the burst, bowed one way, bowed the other, it truly doesn't matter which. Inflation blew it up so colossally that any patch you could ever hope to see got stretched enormous. And a patch that big, cut from any curved thing whatsoever, looks flat, dead flat.
So it's not that the universe was somehow carefully balanced on the pencil point right from the very start.
Not balanced at all. Stretched. Whatever curve it had got ironed clean out. The wrinkles didn't get delicately balanced. They got pulled flat. Like ironing a shirt by yanking it out to the size of a continent. Any wrinkle at all, on that kind of scale, is smoothed down to precisely nothing.
So the knife edge stops being a miracle you have to explain. The universe is flat because it was stretched so violently that flat is simply what any patch of it is forced to look like now.
Flat stopped being a miracle and became the only thing that could possibly have happened. 2 bills, 1 coin. And here is what I love most about it. Nobody sat down and cooked up inflation to explain flatness and smoothness, one at a time, patching each hole with its own separate bit of plaster. It was one single idea, one burst, and both holes closed at once. Together, as one package.
And when one clean idea goes and pays 2 entirely separate debts you weren't even trying to pay together.
You sit up straight. That's the universe leaning over and quietly telling you that you might actually be onto something.
All right, but you promised me a third thing, a gift from the register I never even asked for. And knowing you, this is the one you've actually been excited about all night. The 2 bills were just to get me in the door.
You know me far too well. This is the one. Because everything so far, smooth, flat, is inflation ironing the universe out, making it uniform, calming it right down. But the universe we actually live in isn't perfectly uniform at all, is it?
No, it's lumpy. Gloriously, riotously lumpy. And that was a whole other evening of ours. The baby photo isn't perfectly smooth. There are faint ripples in it, tiny hot and cold speckles. And those speckles are the seeds of everything. Gravity spends billions of years pulling on the slightly denser spots, making them denser still, until they grow into galaxies and clusters, and that whole vast cobweb of light strung right across the sky. The cosmic web. All of it grew out of those first faint ripples.
The cosmic web, grown from the very faintest of ripples. So here's the question inflation now has to stand up and face, and it's a mean one. If inflation ironed everything so flat and so smooth, stretched every last wrinkle out to nothing, then where on earth did the ripples come from? Where did the lumps come from if inflation's entire job was to smooth things out?
Yeah, that's a real problem, that. You can't have it both ways. Either it smooths absolutely everything, in which case there are no ripples, no galaxies, no us, or it leaves the ripples behind, in which case why is everything else so maddeningly smooth? So which is it?
It's both. And the reason it manages to be both is the single most beautiful idea I know in all of physics, and I have been quietly saving it for you all evening. To get to it, I first have to tell you something about empty space that you are not going to want to believe. Empty space is not still.
Empty space is not still. But empty space is the very definition of nothing happening. That's what the word empty means.
That's what it looks like from up here, at our size. But go down small, down past the atoms, down to the very finest grain of things. And empty space is not a calm, dead nothing at all. It jitters. It shivers. Down at the smallest scale there is, the vacuum is restless. A constant flickering fizz, tiny fluctuations bubbling up and vanishing again, up and down, everywhere, all the time. Empty space, looked at closely enough, trembles.
And I have somehow never once noticed this trembling because
it is fantastically, unimaginably tiny. It's down at a scale so small, it has no bearing whatsoever on anything you will ever see or feel in your life. A microscopic jitter, a quantum jitter, the very faintest possible restlessness, on the very smallest possible scale. In the ordinary run of things, it's far too trivial to matter to anything as big as, well, anything at all. It is the twitchiest, most negligible thing in the whole universe.
Except, you're telling me all this on the one single night we've been talking of nothing but a machine whose entire job is taking the smallest things there are and blowing them up to the size of the sky.
There it is, there it is. You've got there a full step ahead of me. Inflation reached in and grabbed those microscopic jitters, those tiny, trembling quantum flutterings in the empty vacuum, and it stretched them. The very same colossal stretching that flattened the pencil and flung the two patches apart, it did to the jitters too.
It blew up the trembling itself.
It took the smallest, most trivial trembling there is anywhere, and it blew it up. Doubled and doubled and doubled, until those faint flutters were stretched clear across enormous reaches of space. And when the burst finally ended, there they were, frozen in place. Faint ripples printed right across the whole young universe. A slightly denser spot here, a slightly thinner spot there. The jitters made huge.
So the ripples in the baby photo, those little hot and cold speckles, those aren't leftover lumps churned up in the fireball at all. They're the quantum trembling of empty space, caught right in the act and stretched up to the size of the sky.
Caught right in the act and stretched to the size of the sky. And then, you said it yourself not 2 minutes ago, gravity takes over the story. Those faint, stretched-out ripples, those slightly denser spots, they pull in a little more, get denser, pull in a little more still, and over billions of patient years they grow.
Into galaxies, into clusters, into the whole cosmic web.
Into the entire cosmic web. The filaments and the sheets and the enormous, echoing, empty voids strung between them. That whole scaffolding, we said, the dark matter clumped up first, with the ordinary matter and its stars pouring in behind. Gravity, patient as ever, doing nothing cleverer than amplifying the faintest head start.
Then let me say the whole chain, because I want to be sure I've got it, not just nodding along. A trembling in empty space, smaller than the smallest thing there is. Inflation blows it up to cosmic size. It becomes a ripple in the young universe, a speckle in the baby photo. Gravity spends billions of years fattening the speckle, and it grows into a galaxy, full of stars, some with planets, some of the planets with people on them looking up.
That's the chain. Every single link of it. The galaxy you happen to live in, the cluster it belongs to, the great luminous web it hangs suspended in, the largest structures that exist anywhere in creation, began their lives as the tiniest possible trembling of empty space. A quantum flutter, blown up in the first instant to a size that could one day cradle worlds.
The biggest things there are were once the smallest things there are, just stretched.
The biggest things there are were once the smallest things there are, stretched. When you look up at a single galaxy, 100 billion stars, unthinkable and vast, you may well be looking at a single quantum jitter. One flicker of restless, empty space, magnified beyond all reason by the very first breath of the universe. The night sky is quantum trembling, written out large enough to walk around inside of.
I need a second with that one, because that is not the sort of everything is connected line you'd embroider on a cushion. That's a specific, physical, falsifiable claim. The reason there's any structure at all, instead of just a boring, uniform grey fog stretching forever, is the fingerprint of the smallest, twitchiest thing in all of nature, blown up huge.
A specific, physical, falsifiable claim. And here is the part that turns it from a lovely bedtime story into actual working science. That trembling isn't shapeless. The jitters have a certain definite character to them, a particular pattern. More of some sizes of ripple, fewer of others. A signature you can go looking for.
And inflation, blowing them all up, tells you in advance what that pattern is supposed to look like.
Not vaguely, in its own precise way. A genuine prediction made about the smoothest, faintest speckles on the baby photo. What sizes of ripple there ought to be, and in what proportions, spread right across the whole sky.
And we've gone and measured the actual speckles. We've got the baby photo in hand, so you can hold the prediction up against the real thing and see if they match.
We can. And the pattern of ripples across the real sky, measured with truly fantastic care from every single direction at once, matches the kind of pattern this picture predicts. That is not nothing. That is an idea about the first sliver of the first second, making a hard, testable claim about the faint speckling of the oldest light there is. And then the claim standing up when we finally look.
Okay, that's the part that properly gets me. It isn't just a beautiful, well, wouldn't it be nice? Somebody stood up and said, if the first instant really went like this, then the freckles on the baby photo will be arranged just so. And then we went and looked at the actual freckles, and they were arranged just so. That's a theory sticking its neck right out and keeping its head.
A theory sticking its neck right out and keeping its head. And that is exactly why inflation isn't some fringe daydream. It's the leading picture of the first instant, taken seriously by everyone who works on this, precisely because it pays those 2 old bills and then predicts the pattern of the seeds on top of it. Smoothness, flatness, and the freckles. All of it falling out of one single burst.
So then we're done. You've paid off both bills. You've thrown in the entire structure of the universe as a bonus, and the prediction checks out against the sky. Case closed. Inflation happened, right?
And now I have to do the thing I always end up doing. The thing this whole show is quietly built on. I have to be honest with you. No, not case closed. Not that clean, and I won't pretend it is.
I could hear that particular sigh coming from a mile off. Go on then. Where's the crack in it?
The crack runs right through the very heart. All night long I've been telling you that the universe ballooned, that space swelled, that inflation stretched things. But I never once told you what actually did the ballooning, what drove it, what poured all that stretching into space, and then, just as abruptly, switched it right back off.
And the honest answer is…
We don't know. There's some stuff, some field, some presence in the very early universe that would have had to do this, and we have not identified it. We don't know what it was. We don't know exactly how it switched on, and we don't fully understand how or why it switched off again when it did.
Wait, so you've got the whole machine here. You can tell me in exquisite detail what it did. You can predict the freckles on the sky to my face, but you cannot tell me what the engine actually was.
That is exactly the shape of it, and it is an uncomfortable shape to hold. It's as though we walked into a room and found all the furniture shoved hard against one wall, the rug rucked up, the curtains streaming sideways. We can read the whole event straight off the evidence. We can even predict where the dust would have settled. But we never once saw the wind itself, and we cannot tell you what stirred it.
And that's not you being coy or hedging your bets. That's a real, honest hole. There could be all sorts of different engines that would leave that same room.
All sorts. There's a whole family of ideas about what the driving stuff might have been, how the burst might have started, how it might have stopped, and they disagree with one another on the details. Some are neater than others. Not one of them is nailed down.
So the general idea stands on firm ground, but the specific mechanism underneath it is still very much up for grabs.
The general idea, a burst of enormous stretching in the first instant, stands on remarkably firm ground, because of the two bills and the freckles. But the specifics, the actual engine, the actual field that drove it, that's an open frontier. People are still arguing hard about it, still hunting for a test sharp enough to tell the rival versions apart.
Is there anything that would settle it, though? Some test that could turn strong idea into confirmed, done, hang up the boots?
There may be, and it's a beautiful one. Some versions of the burst say it should have shaken space itself so violently that it set off ripples in the very fabric of space. A faint tremor in space-time, the kind of thing you met in the last whole season, left over from the first instant and still faintly humming through the universe today. Catch that tremor, read its strength, and you'd have about as close to a signed confession as the first instant is ever going to hand you.
And have we caught it?
Not yet. We've built traps of extraordinary delicacy and gone looking, and so far, silence. Now that silence doesn't sink inflation, because plenty of the versions whisper too faintly for any trap we've got to hear them. But it does mean the clincher isn't in our hand. The smoking gun is still out there in the dark somewhere, if it's there at all.
So it's that strange, lopsided situation where the big idea is strong and the mechanism underneath is a genuine mystery.
The big idea is strong, and the mechanism underneath is a mystery. And I would far rather you walk out of here holding both of those at once than let you leave thinking we've got the first instant tied up neatly in a bag. We don't. What we've got is a superb sketch of the shape of the first breath, confirmed in some of its boldest predictions, with a great question mark sitting exactly where the lungs ought to be.
You know, I keep noticing that every single episode of this thing ends in almost the same place. We build up something absolutely staggering, the expansion, the fireball, the dark matter, the dark energy. And then, right at the very end, gentle as anything, you point out that the most important word in the whole story is one we still can't actually define.
You've put your finger on the secret of the entire subject. Cosmology is a magnificent story built up around a mere handful of enormous question marks. And that isn't a failure of the thing. That's exactly where the science is still alive. A field that could hand you the answer to everything would be a field with nothing left to do.
All right, let me try to hold the whole night in my two hands at once then. In the first sliver of the first second, before the fireball, before the first atoms, before the first light there ever was, the universe took one single colossal breath. It ballooned, doubled itself over and over and over, blew a tiny, already agreed patch up until it became our entire sky.
And that one breath did three separate things all at once.
It ironed space perfectly flat. It made opposite horizons match without ever once letting them speak a word to each other. And it stretched the tiniest quantum trembling up into the seeds of every galaxy there is. The first instant is written all over the oldest light and all over the shape of the night sky.
That's the whole night. Every word of it. The first breath of the universe. The most violent, most extreme, briefest thing that has ever happened anywhere. And its fingerprints are quite literally everywhere you turn to look, if only you know how to read them.
The first breath. I like that a great deal, and it makes me want to ask the greedy question, the one I always want to ask you. If that was the first breath, the very beginning of it all, the universe just getting going, all that violence and swelling right at the front of the story,
Then what, you're wondering, about the last breath?
that is exactly where I was heading. You've spent this entire night running the whole film backward, all the way to the first flicker, just to find that burst. But the universe isn't only a thing with a beginning, it's got a middle too. We're standing in it. And that means it must, somewhere, have an end.
And we already know something about which way it's headed.
We do, don't we? From last time, the gentle push.
The third animal in the third cage. Today's dark energy, that soft, patient acceleration going on all around us right now, the expansion quietly speeding up as we speak. Tonight we ran everything backward, all the way to the beginning. But that gentle push isn't pointing backward at all.
It's pointing forward, so we could do the exact opposite of everything we did tonight. Instead of rewinding down to the first instant, we just let the film run. We take that acceleration we caught the universe red-handed doing, and we follow it forward, all the way forward, and we ask the very last question there is. Not how it began, how it ends.
How a universe dies. And I'll warn you right now, the far future is a stranger, lonelier, colder place than the fierce, bright beginning we've spent this whole season standing in. Running the story forward doesn't take you to another fireball. It takes you somewhere very, very quiet.
Then that's exactly where I want to go next. We've stood together at the first instant tonight, the first breath, the burst that smoothed the whole sky and seeded every last star. So next time, take that gentle push and run it all the way out to the end of time and tell me the final chapter. Tell me how the lights go out, one by one. I'll bring a blanket. I've got a feeling I'm going to need it.